My name is Ken Martin. I have a inertial profiling company called Sam Roads Incorporated. Today I'd like to explain what a high-speed inertial profiler is and consists of. A profiler vehicle has a measuring system much like you would for weight of an object, pounds, distance, inches or miles, feet. The roadway smoothness has its own scale called an International Roughness Index. A high-speed inertial profiler is a vehicle that consists of pieces of equipment, including a laptop computer docked adjacent to the driver of the vehicle. It has an accelerometer. An accelerometer is an instrument that measures relative height along with lasers. Lasers on a high-speed inertial profiler are pointed towards the asphalt in each wheel path. So on our vehicles, we have lasers just in front of the rear wheels. And as we drive down the road, these lasers are taking a height measurement from the frame of the vehicle down to the asphalt, and it takes these measurements every inch of forward progression. There is also a distance measuring instrument on the high-speed inertial profiler that will determine the distance traveled. The vehicle also consists of a GPS positioning sensor. As I collect the data driving down the road, GPS information is also being recorded. The inertial profiler machine has to be calibrated before performing runs on a daily basis. The calibration consists of verifying the tire pressure on all four corners of the vehicle. The accelerometer is calibrated. The laser height reading is calibrated. The distance is calibrating, as well as a static and bounce test to make sure that the systems are all working together properly. Once this is completed, we drive down the road, and the system, it records the roughness in the road. It also records dips as well as bumps. We collect two sets of data. One data is for your local roughness in the road or a bump. This determines an IRI value depending upon the severity of the bump. The higher the bump or the lower the dip, the higher the defect value is. The system also creates a medium roughness index, MRI, on the roadway as well. MRI is the amount of smoothness or roughness traveled over every tenth of a mile. So if I were to profile a 5-mile long length of road, I would have 50 segments of a tenth of a mile, where each tenth of a mile it would give me a MRI reading. And this reading is a good way to translate it would be how much suspension travel takes place in the vehicle over each tenth of a mile. So as you roll down the road and your suspension is coming up and down, this is actually being measured, and it will give you a value of a ride quality. So to sum up, we are able to detect localized roughness, IRI, and we're able to gather ride quality over every tenth of a mile, MRI. In a moment here, we're going to take you out to, we're in Sacramento County in the city. We're here at the near the intersection of Freeport Boulevard and Florin Road. We came over here and did 2 lanes of roadway where the city of Sacramento had several inches of multiple layers of asphalt placed upon the ground over many decades of time. The traveling public was making several complaints to the city of Sacramento regarding the ride quality of this road, and the public felt that their vehicles were being damaged by how rough the road was. We did almost a half-mile of roadway out here on 2 lanes where we profiled the road, determined its roughness, got together with a milling company, specifically ANRAC, and we came out here and we milled this roadway. This roadway had between 175 to 240 MRIs. So state highways 75, this road was averaged near the 200s. When we got done milling this almost half-mile segment of roadway, 2 lanes, we got it down to about a 79 average. So we more than doubled the ride quality of the roadway working with the milling company in order to get a smoother pavement. We removed anywhere from a ½ inch to an1.5 inches of asphalt, depending upon the variation of the defects in the road. And I'm not talking just bumps and dips, in order to be able to get a smooth surface all the way through. We ended up on 1 lane, we also had 83 defects over a 180 IRI on lane number 1. When we completed with 1 pass of micro milling, we had 2 defects left. Now the city of Sacramento did nothing further than that, other than restriping the road and opening it up to the public. It is my understanding from talking to the folks at the city of Sacramento, as soon as they repaired this section of roadway with no new overlay, no anything, just removing a section of a layer of asphalt, they received very many kudos from the traveling public who drive this road on a daily basis. Approximately 5 years ago, Caltrans switched from the push profilograph to the inertial profiler due to a better ride quality in the end. What Caltrans has discovered through this application is the motoring public and big rigs now going down the road don't hammer the surface quite as often, because we do end up with a much smoother treatment on the roadway. And Caltrans is looking for longevity, like everybody should be, of their roadways. And without having as many defects in the roadway, it's been proven that the longevity of the final surface treatment will be much longer, and also give the taxpayers a much more smoother ride on their roadway, better fuel economy, and less damage to vehicles. Okay, on March 22nd, 2017, I came out and profiled this road right behind us, Freeport Boulevard. We did a little over a 4/10 of a mile. On this roadway, we ended up with MRIs of 239, 155, 159, 156, and 150 for an average of 175. Now this is your ride quality over a 1/10 of a mile. For localized roughness of bumps and dips, we ended up with a list of 83 defects. Soon we'll be showing you this road. Afterwards, on April the 21st of 2017, when we corrected this road's ride quality, we came out with a 73, a 76, an 85, a 82, a 74, for an average of a 79 MRI quality. So we doubled the ride quality smoothness, and we ended up with a list of 2 defects over 180 IRI. Now originally we had 83 over 180, and at the end of the day, with a couple hours of work, we had it down to 2 right here. You can see our GPS line traveling down the area that we profiled before the road was repaired. And here is the completion of the micro milling of the roadway. This particular segment of my computer screen shows the ride quality in real-time GPS when I am over the surface that I profiled. On this particular surface, it always shows a red and a green line, and it shows the value of the defect on the top box. But on this bottom box, what this shows is the true profile of the road. As you can see, there's a scale to the left, and this is in inches. So I'm able to go through and determine in segments of the roadway where I need, from this point to just past this point, I need to take out at least a half of inch of roadway in order to achieve smoothness. Now, we don't want to take out the roadway just to even half an inch and end up with the similar profile of what the road had. We have the micromill maintain a level plane and remove in variable depths in order to achieve the ride quality that everybody desires. Okay, here we're going to collect a sample of this roadway. We have a speed bump coming up ahead, and for situations like this, I'm able to exclude that data and then resume collecting the data. Obviously, the speed bump is going to be a defect that's not going to be corrected. This section of roadway that we've just ran is approximately 4/10 of a mile long. I ended up with an average of a 410 MRI, which is very much on the high side. We ended up with 27 defects over 180 IRI, with 2 of the defects being over a 1,000 IRI value. So as you can tell by the video, the quality of the road as far as the surface pavement, 8 years old, doesn't have any alligator cracking, any longitudinal or lateral cracking. It seems to appear though it would shed water very well, yet the ride quality of the road is I would say less than adequate for what the motoring public, the taxpayer, would care for.
So as you can see, we've accomplished maintaining the pavement surface, the asphalt itself, with the seal coat. The challenge is, however, we haven't addressed the rideability issue. So with the combination of high-speed inertial profiling, then with micromilling prior to the placement of a GRCS double chip seal over fabric, you end up with the optimum of both at far less cost than any other procedure.
Okay, we're in El Dorado County, California. I picked a section of road, Marshall Road. I collected data on this road in June of 2017. I know just from watching this road, this is my neighborhood where I have lived for over 20 years, that this road is a struggle for El Dorado County because of its steep grade and variabilities on the road. There's been some recent dig outs that have been done and replacement of HMA, and we are going to see the difference in ride quality since the application of some of these dig outs have been made. As you can see ahead of us in the roadway, there's a lot of alligator cracking in this area, which will obviously allow for water infiltration. And one of the biggest differences between this road and the other roads that we've filmed down in Sacramento County is that this area up here receives at least twice the amount of rainfall each year that Sacramento County does. Okay, we've analyzed this road. As of today, there are 768 IRI defects over this approximately 4 3/4 mile long road. and the IRI defects of 768 are over 180 IRI value. On the MRI, we have a 199.49, so almost 200. I have 787 defects. Now we will turn around here shortly and collect the same roadway going in the opposite direction, westbound. Okay, we're going to collect data on westbound Marshall Road. We had a section of roadway up here that was repaved sometime late this last summer or fall, and I'm going to make a special note on how the repaving of the dig out area compares to 10 months ago and after they did the dig out. Okay, here's our dig out area. Just a small portion of the top of the roadway could be removed and give a much better ride quality. This side of the road feels like it's much more problematic due to it being located on the downhill slope side of the mountain. Okay, we've just ran this westbound section of Marshall Road, 4.68 miles. Today we received an average MRI of 204.50, and we have a total of 732 IRI defects. When I ran this project 10 months ago, we had a 214.44 MRI, so that's been reduced due to some of the new dig outs that have been completed along the roadway. And we have 668. We had 668. Now that number has climbed to over 700. And the 214 to a 204 is an improvement. I also noted that I was going to show you the section, one section dig out that was repaired. That dig out section took place from basically 3.9 to 3.7. Downstationing approximately 0.2 of a mile. So 3.89, we had a 216 and a 188 MRI. And in the past, it was a 130 and a 149. So as you can see, this section of roadway, even though it's been repaved, the rideability has become rougher after the dig out and replacement. This section of roadway will fail much quicker than what the duration of that roadway was in the past before it had its dig out and repaving, just due to the roughness rideability of the road.